So what I want to talk about is exactly what the title is. What are the roles of the economic factors in lift design? And the design considerations that we normally have are quality of service. So quality of service is, waiting time and to a lesser extent transit time. We heard a lot about the relative values of those this morning. And then secondly, quantity of service, generally reflected in terms of handling capacity. But then we also have economic factors that are only implied. So it's not a good idea to be too economical and have one less lift than you need, because then the building gets a bad reputation and can't command the high rents. At the same time, there's another consideration, is we can always give great quantity and quality of service if we only put in 2 more lifts than the building needs. But that has a negative consequence to the person who owns the building. And so one of the concepts that's very important to understand, that's important to building operators, is return on investment. And return on investment is the income divided by the asset value. So you want to get a return on your investment. So if you think about banking, there was a time when you could put money in the bank and they would pay you interest. It's no longer the case, but it's a good concept. It's been around for 5,000 years, I think. It's the second oldest profession in the world is banking. And so when we calculate return on investment, we want to look at what is the income. In this case, we put 100 million pounds, euros, dollars, doesn't matter, in the bank, and they give us 3 million in interest. So our return on investment is 3%. And you won't get that today, but you could. But you also have to consider that that's how we would invest. You invest your own money in a bank or in stock or whatever, shares, and you're looking for a return on your investment. Well, buildings are investments. And so people build buildings as investments, and they expect to make money, and they expect to have a return on their investment. And so how do you maximize your return on investment on a building? Well, one way is you take a look at this is a building, floor plan of a building, and the one way to maximize the return on the investment is how much of that building is net lettable area. Well, you can't lease or rent the toilets, you can't lease the mechanical spaces, you can't lease the elevator shafts. So what a building owner is concerned about is what can he actually rent? And they're looking at a percentage of the net to the gross square meters. And there's one lift consultant in the United States said to me, he said, "Rory, we're not in the elevator business, we're in the real estate business." Because their job is to advise people on how to maximize their return on their investment. So let's take a look at hoistway size as one of the things that this typically in Europe, not so much the rest of the world, a lot of the lifts have an aspect ratio where the lift is deeper than it is wide. You see this a lot. And for the same size, they'll also offer, so in this case, the hoistway size required is 5.16 square meters. And I got this out of one of the major lift companies' UK brochure, but all of them have the same similar size, similar type lifts. They also offer the same lift. This is a 1,000 kilo lift at 1 meter per second. They also offer one in this aspect ratio, essentially the same price. And so you can see it's 3.94 meters. So what's the difference? Well, the difference isn't much. The difference is, if we look at it, 1.22 square meters. So not a lot of space. So what's the big deal about 1.2 square meters? Well, it's a little more than that, because that's per lift. And this building had 2 lifts, 6 floors. And so there's a total of 14.67 square meters more net lettable space for the same initial investment. So how does that work out? Well, I took a medium market, Birmingham, not too far from here. It's not London, it's not Hong Kong. But even there, the rental rate in Birmingham is 463 euros per square meter per year. So what does that mean? We multiply that, and it's 6,700 euros per year, which means for the same investment, you're going to have that much more return. It doesn't sound like a lot of money, but it is. It's free money because it doesn't cost you anything to do this. You just make the building more efficient. So there's other things like where you can use economic engineering to evaluate proposals. One of them would be a sales proposal that a lift company says the following: we can provide regenerative drives for only 350 euros additional, and you'll save enough energy to get your money back in less than 3 years. Now, sounds interesting, 3 years, but what the salesman didn't understand is, well, in Birmingham, that's 18 cents, euros. And so each lift would then save 120 euros per year. So, yeah, the 3 years seems feasible, except he didn't use the right equation. The right equation, because it's 2.89 years, the right equation has to look at after-tax cash flow. So you have to consider that if you're going to make more money, you're going to pay more in taxes. So you have to discount that. So you're really looking at the asset cost divided by the annual after-tax cash flow. This is the payback method. It's used by a lot of people in a lot of industries. It is a rule of thumb. It is not scientific, and it is not the best tool, but it's a quick way to eliminate things. So I remember years ago I was involved in a project where a competitor said, we can put SCR drives on your existing elevators instead of MG sets, and you'll save 40% on your energy. And they put recording watt-hour meters on it, and it came back that yes, they could save enough that in 50 years they could pay back what the cost was. So using a payback method, you wouldn't go any further. But let's go further in this case. And so it's $96.72, so it's 3.61 years, not a bad payback, but it's not scientific. And it doesn't consider the time value of money. And the time value of money is simply stated, a euro today is worth more than a euro a year from now. Now, how does that work out? Well, if you put the euro in the bank or in an investment that pays 8%, your euro a year from now is worth 1.08 euros. At the same time, if you put 93 cents in the bank or in the investment at 8%, a year from now it's worth a euro. There's a joke about a lottery that you pay $1 for, and if you win $1 million, but it's $1 a year for 1 million years. So the longer time you go out, the less the money is worth, because $1 a year from now, a million years from now, has no value to me. So, and probably anybody else in this room. So the proper way to evaluate an investment is a tool called net present value. And net present value follows this equation. I'm just going to go through it real simply. The variables here are T represents the time period. In this case, we'll use 1 year time periods. We could use 1 month. And the project's life. So we'll say in this case 20 years. So we figure these lifts that we're going to put the variable frequency drives on will be ready for modernization again in another 20 years. And then we say, okay, what's the after-tax cash flow? Well, we already came up with that. That was that value we had. And then K represents the required rate of return. Now, the rate of return is similar in concept to return on investment. How much do you want to make on your capital investment? And that depends on the company, the type of investment, and it's an arbitrary number. It's a way something that management has to determine. And when you do this, if you come up with a net present value equal to or greater than 0, it meets your return on investment requirements. So that's what they call required rate of return. If we apply this to the regenerative drives, we use this, and our net present value, well, we use 1 year periods, we use a 20-year life, we use the 96.72, and we're saying 8% is the rate of return that we decided we wanted. There's no right number there. It's whatever fits your risk profile and your cost of capital. But the initial investment is 350. And so it returns a net present value of 599 euros, so that would mean that it meets our hurdle. This investment will return more than the 8%. It also means that, let's call it 600. If we were to pay 950 euros for this investment, we would still get our 8%. So this would be a way to qualify this particular investment. So there's a lot of high-tech lift solutions being presented today, being developed today. If you read through all of the patent applications and patents that have issued, all of the multinationals are developing something with more than one lift in the same hoistway. They all have patent applications in for something like that. So there's going to be some high-tech solutions in the future, and they're going to require you to do a financial analysis to see if it works. You can just take double deck. Does double deck make sense? Well, you have to, there again, you have to look at what floor space are we going to liberate by having a double cabin versus two separate hoistways. So you can use the same thing. So let's take a proposed building in Birmingham again. So we get to be 18 stops. It's going to have 6 lifts, 1,275 kilogram capacity, 3 meters per second. And the hoistways layout is going to look something like this: 3 lifts across from 3 lifts, very conventional design. And so this is a proposed system, but one of the lift companies comes along with a new high-tech solution, and the high-tech lift is something really exotic, like a transporter, and and it's going to save a lot of square meters. So how is this going to save square meters? The only problem is this high-tech lift is going to cost 600,000 euros more. But what's it going to do? It's going to have 4 some kind of lifts in there instead of 6. And so it's going to save 19.6 square meters per floor. Okay, so that begins to be a fair amount of area. And we don't know how they're going to do this. We don't care. We're just trying to see if it makes sense for us to spend an extra 600,000 euros on this building. So we apply the net present value equation. And the one thing we have to do, you'll see here, we have the 600,000 is the additional cost. But you see that K, which is your required rate of return, is 15%. And that's because the building had been budgeted without spending this, and now they're going to have to borrow the money to do it, so they want a higher rate of return. There are companies that because of capital allocation, want 20 and even 30% returns before they'll take an investment. So it's purely arbitrary. But in this case, we'll say, okay, we want a return of 15%. Does this still make sense? And so the net present value came out to be 64,585, which is greater than 1. And so this will return, give the person the rate of return they're looking for. It will give them the 15%. So this is a way to qualify asset purchases. It's a way to quantify what the true value is in today's terms of a future stream of cash over the expected life expectancy. If you go from 20 years to 30 years, it doesn't change a whole lot because those last 10 years aren't worth so much. They're a long time away. So in this case, it would make sense to use this high-tech lift based upon the square footage, the square meters that you're going to pick up. So that's where I think when you start looking at the high-tech solutions that are available, they don't work in every building, and they don't work because they usually cost more money. But they do work in buildings where you can pick up enough square meters to cover their costs. And you have to look at not just the hoistways, but the lobby spaces as well. And if you look at all of that, then you can make a financial judgment. Should I invest more for less and get more square meters to lease? This can also be applied to modernizations. And with modernization, you have to look at doing a modernization, whether it's a high-tech modernization or just a conventional modernization. What's that going to do? How is that going to improve my return on investment? And there you want to look at, am I going to lose rents because my building is not as new, not as efficient? And will this prevent me from losing rents in the future, my rental rate going down? If you apply that, then you can use the same net present value tool to evaluate whether or not a modernization makes sense for a particular building. Because buildings are in competition with each other, and what happens is when the building gets older, the new building down the street is going to try to steal the tenants and take the money. That's business. So the conclusion is that I really believe that we have to address quality and quantity. They're very important. It's a principal part of what we do when we're doing traffic analysis, when we're designing a lift system. But we at the same time have to look at economy, and economy is also important because we're all in the real estate business, whether we realize it or not, and because our product goes into buildings and is a critical product. If the lifts don't work, the building doesn't work, and we all know that. So, question?